Hello class 9, this is part 2 video of lesson the periodic table, and today we are going to cover Newland's law of octaves, limitations of Newland law of octaves, Mendeleev's periodic table, features of Mendeleev's periodic table, and characteristics of groups in Mendeleev's periodic table. So let's start. John Newland was an English scientist who discovered a law named Newland law of octaves. By 1866, 56 elements had been discovered, that is, 26 more elements were discovered between 1829 and 1866, since we know that during Dobryna's triad only 30 elements had been discovered. So in his law, he states that if elements are arranged in order of increasing atomic mass, property of every eighth element repeats. Like we have a musical notes sa re ga ma pa da ni sa or do re mi fa sol la ti do, where ni and ti is the seventh notes, and when it comes to eighth notes it will be sa or do. Similarly, if elements are arranged in order of their increasing atomic mass, the property of first element and eighth elements will be similar. So here hydrogen is the first element and fluorine is the eighth element, so they will have similar property. Likewise, there are other elements also like chlorine, cobalt and nickel, bromine, so they are also in the same slots where first and eighth term are similar, so they will also be having similar properties. So this is the law given by Newland. Now the drawbacks of Newland's law of octaves. First is, this law was correct only up to 17 elements, that is up to calcium. Newland assumed that no more elements would be discovered in future apart from 56 elements. This is the second drawbacks. And the third is, in order to fit elements into octaves, he adjusted two elements in the same slots. So you can see this is the table given by the Newland. So the first is only up to this place, up to calcium, this law is fulfilled. And you can see there are 56 elements. He said that no more elements will be adjusted or no more elements will be discovered in future. And most importantly is, you can see this chlorine, cobalt and nickel and bromine are in the same slots, though cobalt and nickel is a metal which have totally different properties as comparison to chlorine and bromine. So these three are the drawbacks of Newland's law of octaves. Next topic is Lothar-Meyer atomic volume curve. So this is the topic given by Lothar-Meyer. So we have already seen what is atomic mass or atomic weight. Now we have a new topic named atomic volume, explained by Lothar-Meyer atomic volume curve. So atomic volume is defined as the volume occupied by 1 gram atom of an element. Like if we have any of those atom, so that atom weigh actual 1 gram and we need to keep it in any other container, so the area occupied by those 1 gram atom of an element is known as atomic volume. Mathematically, it is defined as atomic volume of element is equals to atomic weight divided by density of the elements. Lothar-Meyer plotted a curve between atomic volume of different elements against the atomic volume of the given elements, and he found that similar elements occupy similar position on the curve. So you mark that word similar elements. Okay, how it is similar, we're going to see it in the next slide and next curve. So the observation that we get from the Lothar-Meyer curve, let's see. First is the most electropositive elements. Note that electropositive elements means the tendency of an atom to donate electrons and forms positively charged cation. So most electropositive elements, that is having only one electron in the outermost shell, like lithium, sodium, potassium, rubidium, cesium, they occupy the peak on the curve. And the second observation is less electropositive elements, that is having two electrons in the outermost shell, like beryllium, magnesium, calcium, strontium, barium occupy the descending position on the curve. We'll see it in the curve in the next slide. And finally, the most electronegative element. Here, note that electronegative means tendency of an atom to accept an electron pair and form negative charge. Like fluorine, chlorine, bromine, iodine, it's 1 electron, that is, they have negative charge. They occupy ascending position on the curve. Let's see in the curve. So this was the curve given by Lothar Meyer. Now you see the most electropositive elements, they are in the peak, and little bit less electropositive elements, they are in the descending position on the curve, like magnesium, beryllium, calcium, strontium. And all the halogen atoms, that is fluorine, chlorine, bromine, iodine, they are on the ascending position on the curve. So this was the curve given by the Lothar Meyer, which gives us an idea about atomic volume comparison to atomic mass. Our next topic is Mendeleev's periodic table. So Mendeleev was a Russian chemist and inventor of a periodic table of an element, and which is also known as Mendeleev's periodic table. So by 1869, 63 elements had been discovered. So during the time of Newland law of octaves, there was 56 elements. So now when it comes to Mendeleev's periodic table, 63 elements had been discovered, that is 7 more elements had been discovered. So Mendeleev was nominated for Nobel Prize in 1906 for his work, but sadly he died on 1907 before receiving Nobel Prize, before the ceremony. So what was the law, or what was the thing that was given by Mendeleev's periodic table? Let's see. Physical and chemical properties of an element are the periodic function of their atomic weight. So if any of those elements are arranged in order of their atomic weight, their physical and their chemical properties has to be similar. This was the law given by Mendeleev. Now the features of Mendeleev's periodic table are: first, he arranged elements in a tabular form in order of their increasing atomic weight. Similar to that of Dobryner's and Newland, he also tried to arrange all those elements in a table in order of increasing atomic weight. Second is, he divided the table into vertical columns, which is known as groups, and he also divided the table into horizontal rows known as periods. So now, what is the idea that we get to know from these groups and periods are: if there is a group, we need to know that the elements present in each group will have similar property and the same valency. In the periods, what we get to know is, while going from left to right, that is on the horizontal rows, the property of metallic character decreases to non-metallic character. We know that metals have a property like malleability, ductility, conduction of heat and electricity. So while going from left to right in horizontal rows, the metallic property decreases from non-metallic. So that is why you have seen, whenever in a periodic table, in an extreme left there is always metals, and in extreme right there is always non-metals. So these three are the features given by Mendeleev's periodic table. This is the table that was formed by Mendeleev. So you can see there are 8 vertical columns, which is known as groups, and 6 horizontal rows known as periods. So watch carefully. You also observe that in one group there are 2 elements also, which is known as subgroups. So let's move forward. So this is the periodic table given by Mendeleev, having 8 vertical columns known as groups and 6 horizontal rows known as periods. Now the characteristics of groups in Mendeleev's periodic table. Now the first is, the group number represents the valency. Like I have already told you, if the elements are present in group number 1, so all the elements present in group number 1 will have valency 1. If it is in 2, all elements will be having valency 2. If it is 3, so it will be having 3. And if it is having 4, it is also 4. And if it is having 5, so that is 8 minus 5 is equals to 3. When it is in 6, it will be having 2. When it is in 7, it will be having 1. And when it is 8, it will be having valence 0. So that similarly that goes on. Number 2 is the elements in the same group will have same properties comparison to other group. So if all the elements are present in group number 1, so all elements will be having similar property, but there are so many elements, so they are arranged in different groups. So the group 1 element will be having similar property, but group 1 and group 2 elements will be having totally different properties at all. Now lastly, when it comes to subgroups like potassium and copper, you can see they are in the same subgroup. Likewise, there are many other elements also in the subgroups, so they will be having total different physical and chemical property. Let's say we have a calcium and copper. Calcium, oh sorry, not it is not calcium and copper, it is potassium and copper. Potassium is a very reactive metal, but copper is little bit less reactive metal. So that depending upon their atomic weight in the subgroup, they will be having totally different physical and chemical properties, though they belong to the same subgroup. So this is all about characteristics of groups in Mendeleev's periodic table. Thank you.